Welcome to today's presentation of Wastewater and Environment Decision Support Tool. My name is Matej Cerk. I come from Water Science Institute. Today I'm going to talk about the Wastewater Decision Support Tool in practice. I'm going to show you how you can use it as if you were a city planner. This is the main screen of the WEMDST application. You can see the river quality at current state. That means that the state that is modeled in 2019. The rivers are colored in colors from green to red. And this represents the concentration. You can see here the concentrations from green are very low, are 1 milligram up to 1 milligrams per liter of BOD5. Then 3 milligrams per liter of BOD5 is colored orange, and 4 and 5 milligrams per liter are colored red. Then there are these dots. The dots are agglomerations. For example, this one, you can see in the upper right corner, it's Skadar agglomeration or Skadar city with a population of 74,000 people, and there's no treatment options. Therefore, the circle representing Skadar city is colored orange. If there's a green circle, it means that there is some treatment applied for the agglomeration. For example, Podgorica wastewater treatment plant I'm showing now. Let's say that we want to build a wastewater treatment plant for Skadar city. We can see we have two agglomerations here. One is Bacalik and Skadar. We will build a wastewater treatment plant for Skadar city, place it like here somewhere, and then see how does this affect the concentrations downstream. So you have to press this button, Start Planning, and we can start planning a new scenario. You have two options, for city planners and for state planners. If you want to build just one wastewater treatment plant, the best option is to go for city planners. Then you have to select what kind of scenario you want to save. So let's say Skadar city. We will name the scenario Skadar city wastewater treatment plant, and we will give a short description. Planned for the year 2022, used only for presentation. Okay, start planning. We have a screen where we enter the data of planned wastewater treatment plant and planned sewage network size. Here we can see we have a current state, existing infrastructure, and for Skadar city in Albania, there is almost 75,000 people living there. All of them are connected to sewage, and none is treated. That means that all of the sewer is polluting rivers directly. So current loads to rivers are almost 4,500 kilograms of BOD5 per day, almost 900 total almost 900 kilograms per day of nitrogen and 225 kilograms of phosphorus per day. So we will start a new treatment plant. It's a secondary treatment plant. We will plan it for, let's say, 75,000 population equivalents. Then you have an option to select efficiency values. You can see here that current efficiency values are 90% for BOD5, 20% efficiency for total nitrogen, and 10% for total phosphorus. If you tick this box, you can change those percentages to different percentages that are directly that you obtain from the constructor or from the project. But we have two default ones preset. So if you select tertiary treatment, you see that the BOD5 efficiency is the same, but the nitrogen and phosphorus efficiencies of wastewater treatment plants are much higher in tertiary than secondary. Okay. Plant sludge treatment. You have two options: conventional dewatering and disposal, or reed beds. We will go with reed beds because it's a better option, although a bit more expensive. Plant additional sewage network. Okay, we know that we need to build another 30 kilometers of sewage network. Plant total population, including total industry population equivalents and total tourism population equivalents. Okay, we will just estimate roughly the same population, so I'll go with 75,000, and all of them will be connected to the sewage, and all of them will be then also connected to the wastewater treatment plant. Now I can save and show results. You can see that there are two things happening. First, we got a new box with the blue colors where there are planned loads calculated. And then if you go a bit down here, you see that there is some calculation going on in the background. That means the concentrations in the rivers need quite some time to calculate, a bit over 1 minute. So let's first talk about the released loads that are calculated to emit to the river, and we will just then see the concentrations later. Okay, we have a plant population that's quite the same, but the loads you see are very much smaller, from 4,500 to 450. Also, nitrogen and phosphorus is a bit smaller because we have secondary treatment. Then we have another three columns, three rows that are related to costs. We have a plant wastewater treatment plant with a capacity of 75,000 PEs of secondary treatment option, and the capex, so the total costs for the wastewater treatment plant, are estimated to be €10.5 million. and it would cost you €500,000 to operate annually. For the sludge treatment, we have selected reed beds. The total cost is a bit over 3 million. The sludge processing annual cost is 90,000 euros, and the sludge incineration costs are 135,000 euros. Then we have a potential treated water reuse. We can reuse water that comes out of the wastewater treatment plant, and if we have to build a disinfection block, which would cost us 120,000. Wastewater disinfection annual costs, or OPEX, would be 50,000. The flow from wastewater treatment plant would be 0.1 cubic meters per second, and that would be enough for 200 hectares for irrigation. Then we can also reuse sludge from the wastewater treatment plant. To build that, we need 34,000, and we would get 20 tons of sludge in 10 years. So it would be enough for almost 400 hectares if there is extensive agriculture. But if it's intensive agriculture, it's for much less area, for much smaller area. So for 775 hectares. The total investment estimation for wastewater treatment plant with sludge disposal we have selected is almost 14 million. OPEX in case of incineration is 740,000, and the net present value in case of incineration over 30 years is estimated to be 25.5 million euros. Operational costs, annual operational costs in case of reuse is a bit more over 500,000 euros, and the net present value in case of reuse is 24 million. Then we also have sewage network investment. We have planned for 30 new kilometers of sewage network that would be estimated for 9 million capital costs, capital expenses. And then if we go below, we see that the calculation is completed. First, what we can see are the concentrations. The SCADA city is now in green color, which means that there's a wastewater treatment plant planned for this agglomeration, not for Bacalec. And the quality in the river downstream improves. You can see here, if I go with the mouse over the river, I can see the model data of BOD5 above 5 milligrams per liter. But if I check the concentrations here, I can get BOD5 of 2.76 milligrams per liter. Of course, there is no effect upstream, since we discharge the water downstream of the city. And here we can see the concentrations. Just go a bit more down. We can see that the SCADA city comes in at kilometer 9 It's here. And without any treatment options, we have the green concentrations here on this axis, and with treatment applied, we have smaller concentrations in the river. What we can also observe here below is the detailed view of the agglomerations. First, if I show you this one, we have Skadar city at kilometer 9 and Bacha Lake at kilometer 14 emitting to the system. And if I show the detailed view, you can see what are current loads, how the current loads are calculated, and how the planned loads are calculated. Thank you very much. That's all for today's introduction in the WEMDST tool. Next time, I will show you how to simulate more agglomerations and that is most suitable for national authorities. Until next time.